Right. Chloe, since you were here last week, right? I have a question for you. Because since Ayman wasn't here and we had a whole class learning about base quantity and derived quantities. I don't know if Ayman you have learned it in school already, but Chloe, can you or do you know any example of base quantities that we have learned? We have learned quite a few, right? Can you give like one example of like a base quantity and one example for derived quantity? Just one each.
Base quantity, we have mass, and for derived quantity, we have area.
Oh, you have area. Yes, very good. Okay, so base quantity is mass. Okay, that's one good example. Derived quantity, area. Okay, thanks, Chloe. All right. Okay, so from these two examples that Chloe gave, right, we can see that just a recap of what we learned last week. Base quantities, right, are all the quantities that cannot be derived from other quantities. Okay. Yeah, thanks, Sarah. Base is length, base quantity is length, derived quantity, velocity. Yes, very good. Thanks, Sarah. Okay. Ayman, do you want to try or not? Have you learned in school? Have you started physics in school? Not yet? Okay. Right, that's fine, that's fine. So yeah, base quantity, you will see that the examples that Sarah and Chloe gave, right? You will see that base quantity cannot be created from other things, must be from itself only. Okay, for example, mass lah, for example, length lah, for example, time. I cannot create time from other things, but area I can create from other things, right? For example, why is area a derived quantity? Because let's make this a bit mathsy. If you have 5 cm, I might give you this simple question. What is the area of this rectangle? This question is for you, huh? 20 cm, yes, 20 cm squared, okay, 20 cm squared, very good, right? 4 times 5, and what you have really done here is taking the length, multiplying it by the, you can call this the width, you want to call it the breadth, or essentially, since both is in cm, you can say that we are taking the length multiplying with another length, right? So from here, right, I just want to summarize whatever we have learned last week so that you don't forget. Base quantity cannot be derived from other things. Derived quantities, you can create from other things. For example, area is the best example that you know. Area is length times length. Okay, area is length times length. Okay, so Ayman, if you are a bit lost, right? For base quantity, you can always refer to this table. Okay, in the first page, you have this yellow color table, right? You must know all these 7. Okay, this one is important. You must know all these 7. This is the base quantities, and anything else that you see is going to be derived quantities. Okay, one of the examples that we have just now was area. Volume also is a derived quantity, right? This whole table is a derived quantity. Okay, so we'll continue with our example 1.4. Example 1.4. Okay. Right. Write the value of the physical quantities in standard form. Although this isn't really in the textbook. Okay, but I find that this is important because there is a lot of values in physics that is going to be very big or very small. Okay, very big or very small. So I realize along the years that some students, they are not very familiar with standard form. Okay, standard form is something that you actually learned in Form 3 maths. Okay, but even if you feel that you're not very good with it, it's fine. We'll go through 10 examples here. Okay, we go through 10 examples here, and I'll teach you how to write numbers into standard form. It'd be very useful for values that are very big or very smaller. Okay, so starting with the first one, we're going to write all these physical quantities in a standard form. Okay, in standard form. Right, there's a mass of an object which is 68,700 kg. Okay, I'll show you one first. I'll show you the first one first, or the first two. Okay, then whoever wants to try, maybe you guys can try also. Okay, so the decimal point for 68,700 is behind here. Okay, let me enlarge a bit. The decimal point for 68,700 is here. We need to bring the decimal to the front so that the number, if I bring the decimal to the front, it becomes like this, right? So that this number must be a number between 1 until 9 point something something. Okay, so this number cannot be 0. It can be 1 to 9 only. So 1 point something is fine. 2 point something is fine. 3 point something is fine. 4, 5, 6, 7, 8, 9 point something is fine. But can it be 10 point something? Cannot. Can it be 68.7? Cannot. Must be 1 to 9 only, the front number. Okay, so very simple. You just have to move the decimal to the front, and it's going to be 6.87. So this is a bit of revision only. Okay, you should have seen this before, right? Even if you forget, never mind. You just focus on this one, and we'll write times 10 to the power of a power like this. Okay, so a lot of people get confused because right now we count again how many position we move. 1, 2, 3, 4. Okay, 4 positions. So the question is, this could either be power 4 or it could be power -4. Does anyone know the answer? Do you think it is 4 or do you think it is -4? Chloe or Sarah or Ayman, do you guys know the answer? No, because I don't know whether you know this. So if you don't know, never mind. You just say don't know. You just type DK. Okay, DK stands for don't know. Oh, sorry, I accidentally messaged Ayman. Hold on now. Yes, that is. Yes, thanks, Ayman. Okay, everyone is saying it's 4. Right, you are right. You guys are right. So I guess you still remember what you learned in maths, which is good, But let's say if you forget already, I teach you how to remember, right? It's very logical one. Okay, from 68,700 is a very big number, right? Suddenly, you are going to make it so small. When you're making it so small, you have to balance it back. Okay, life is all about balancing things, right? So we have to balance it back such that if this one is small, here you will need to make it big. Okay, so it will be power 10 to the power of 4. 10 to the power of 4 is multiplying by 1 with 4 zeros. Okay, 1 with 4 zeros. So we are saying that 6.87 multiply 10,000. I should get back the same value as 68,700. Okay, this one is the same as 6.87 times 10 to the power of 4. Okay, if from 68,000 you make it suddenly become so small, then the power at the back should be a big number, which is 4, not -4. Okay, -4 is a smaller number. Okay, we try another one. Now I'm going to move this one 1, 2, 3, 4, 5, 6. Okay, six positions, 3.26. Sorry, I'm so sorry, I forgot the unit. kg. Must have the unit, huh? In physics, units are very important. Okay, for time here, we have 3.26. Okay, 3.26. Why do I stop the decimal at 3? Because the number here can only be 1 to 9, right? Just now we said 1 to 9. Okay. This one is going to be times 10 to the power of, it's either 6 or negative 6. Okay, it's either 6 or negative 6. You see, from such a small number, 0.000000326, you make it become a big number already. So here has to be negative 1. Okay, if this is big, the back part must be small, or else I will change the value already. Okay, that's the last thing you want to do. We don't want to change the value. We just want to rewrite the number into a standard form, a different form. So like this. Okay. I forgot already how many. 1, 2, 3, 4, 5, 6. Okay, negative 6. Okay, Ken. Chloe, you want to try? The length. This one for the next question. If you're not sure, you just say not sure. There's nothing to be shy about. Okay, we are very chill one. You can unmute your mic if it's, I think it's easier to say if you unmute your mic.
You can wait 1 minute.
Oh, can. Yes. Meanwhile, you guys can try so Sarah and Ayman. You can try for the next 3. See whether or not you can do. Okay, see whether or not you can do. So the decimal point, if you don't see any decimal point, that means it's behind. Huh? Okay, this 402 also, the decimal point is behind here like this. Because it's 15620000000.0 like that. And then now we want to move this decimal point.
Teacher, I got 5.62 times 10 power of 8.
10 power 8. Yes, that's correct. Okay, 5.62 times 10 power 8. So we move 1, 2, 3, 4, 5, 6, 7, 7, 8. Okay. All right. 5.62 times 10 to the power of 8. And then, okay, Ayman, you want to try not? 402 Kelvin. Yes. Very good. Thanks, Ayman. 4.02 times 10 to the power of 2 Kelvin. Okay. And then Sarah, want to try now? Okay, thanks, Sarah. 5.2 times 10 to the power of negative 7. Okay, you move 7, please. From a small number, you make it big. When this is big, right, this one has to be a small number. Do you know that times 10 to the power of negative 7 means? Okay, maybe you guys can write this side. Whenever we say times 10 to the power of 4, it means times 10 to the power of, times something with 4 zeros. Okay. Whenever we say times 10 to the power of negative 4, it means we're doing times 0.0001. Okay, 4 decimal place, 1, 2, 3, 4. Okay, then can you guys also continue and do for area, volume, density, speed, and force? Okay, I'll give you guys a bit of time to do this. And then when you're done, you just tell me you're done. You can just unmute your mic and say you're done, or you just type in the chat and say you're done. Then we'll go through again together the answers. Okay, just a revision practice on standard form. Thanks, Sarah. Okay. So for Chloe, you want to help me now? For the area, what do you get?
3 times 10 power of 5.
3 times 10 power 5. Okay, correct. Meter squared. And then the volume one?
4.5 times 10 power of 7.
7. Okay. And okay. The rest I do lah. So this one is 6 times you move one place, two place. Okay, one place, two place. Make sure you have all the units. Have a good habit of writing the units. Okay, in physics, if you don't have the unit in your final answer, you will lose 1 mark. Okay, so very, very not worthy lah. So make sure you have the units. This is 9 times 10 to the power of, you got 1, 2, 3, 4. Okay, you move 4 place. Yeah, Aiman, actually that's better if you write 6.0. There's nothing wrong with it. 6.0, or this one you want to write 3 or 3.0 also can. That's a very good question. Aiman, if you can, right, you don't need to shy lah. If you send to everyone in the chat, then everyone can see. Then when I answer the time, everyone knows what I'm talking about. Okay, so Aiman asked me if I can write 6.0 instead of 6. Yeah, you can. Okay, both also is fine. Huh? Okay, and the last one would be 1, 2, 3, 4. 5 times 10 to the power of -4. Why -4? Because from such a small number, I make it become a big number already. From 0.0005, I make it become 5. That's quite big, right? So if you make it big, here needs to make it smaller. Okay. All right. So this is just a short revision. And there are some SI prefixes which you should have seen in Form 1, your Form 1 science, all this prefix. So do you have to memorize this? I would say don't need, okay? You don't need to memorize, but maybe you can star a few important ones, okay? Maybe you can star a few important ones. For example, mega, kilo, and centi, milli, as well as micro. Okay, so mega stands for 10 to the power of 6. Okay, mega stands for 10 to the power of 6. So for example, if we have hold on, if we have 40 times 10 to the, of course 40 is not standard form. Okay, maybe I write 4. Okay, 4 times 10 to the power of 6 grams. Okay, 4 times 10 to the power of 6 grams. I can exchange this 10 to the power of 6 with the symbol of capital letter M to represent mega. Okay, so mega stands for your 10 to the power of 6. So if you see anything like this, right, you can straight away say that, oh, this is actually 4 times 10 to the power of 6 grams, right? Mega, you should be quite familiar. Like for example, your usually your pen drive, okay, usually your pen drive, I think you should have heard people ask you, oh, your one got how many gigabyte? Okay, giga is this one. This is the giga that they are talking about, right? So byte is the unit for the storage of your pen drive, right? Gigabyte, usually The short form is GB. Gigabyte means that there are times 10 to the power of 9 bytes. Okay, if you say you got 2 gigabyte, meaning you have 2 times 10 to the power of 9 bytes. Okay, so it's the same meaning one. Mega also the same, right? So I think kg, you are very familiar. We always use the word kg. If we say got 70 kg, meaning is 70 times 10 to the power of 3, because kilo is 10 to the power of 3. Okay, so I just don't want you to, in case you see this in exam and then you feel very shocked. Okay, because some values maybe they just want to because it's a very big value, right? And then they use the mega, for example, and then you don't know what they are talking about, right? Just know that especially the ones that I start, just know that if you see capital letter M, it stands for 10 to the power of 6. Okay, same goes to centi. The one that you are very familiar with is centimeter, right? cm, the one on your ruler, cm, 5 cm. 5 cm is, for those of you who are very pro, you would say that it's 0.05 meters. Okay, 0.05 meters. But if you're not very sure, now you know cm is actually 10 to the power of -2. Okay, 10 to the power of -2 means what? Means my decimal point is here, right? -2 means I need to make it smaller by 2 places, 1, 2. So that's why it becomes 0.05 meters. Okay, so same for micro. Okay, same for micro and milli. Okay, milli also, the one that you are most familiar with is probably millimeter or milliliters. Millimeter or milliliters. Okay, 5 ml, 4 mm, all this you should have heard before, right? 500 ml is 0.5 liters. Okay, why? Because 500 ml is 500 times 10 to the power of milli. We look at the table, -3. So a lot, actually, you don't have to purposely memorize because you know already. Centis make it smaller by 2 places. Milli is make it smaller by 3 places. Okay, so this one will make it smaller by 1, 2, 3. Therefore, 0.5 liters. Okay, so last week, this one, again, is just a revision. So you just put a star on the ones that I put there. Those are the more common ones. Okay, they don't ask nano, pico, hecto, deca a lot. Once in a blue moon, maybe got giga, right? They won't purposely ask you what is the value of mega like that. No, okay, they will just put inside as part of your calculations later on, right? So if in case you ever forget, you see in the question got some weird symbol and you're not sure, you can look at this table. Okay, but don't worry so much. They rarely use all this lah. They like to use standard form more as compared to SI prefix. Okay, they like to use standard form more as compared to SI prefix. Okay, so last week the main thing that we learned was on base quantity and also derived quantity. Okay, base quantity and derived quantity. In this week, the main thing that you are going to be learning is on scalar quantities and vector quantities. Okay, scalar quantities and vector quantities. So we learned that physical quantity, right, can be classified into base quantity and derived quantity. That one you know already. There's also another way that you can classify your physical quantity, which is into a scalar quantity or a vector quantity. Okay, scalar quantity and vector quantity. These two, they are equally important as your base quantity and derived quantity. So base quantity, very simple, got that 7, correct? Got that 7. And then scalar quantity, vector quantity, what is their meaning? Can they ask you the definition or not in exam? Can, right? So this one, you must know. Okay, what is the meaning of scalar quantity? If in exam they ask you, scalar quantity is a physical quantity, right? It's a type of physical quantity. But the very important thing is you need to remember, it has magnitude only. Magnitude only. a lot of people don't know the meaning of magnitude, right? You can bracket at the side here. Magnitude means the value. Okay, means the value or the unit. Okay, means the value or the unit. Okay, then that is what we mean by magnitude. Okay, don't worry, later we will have an example. Then you will see what it means by having a value, okay, or having a unit. Like 5 meter, this one is a magnitude. Okay, later I'll use an example to explain will be better. Okay, and then we also have another one which is scalar quantity. My bad, vector quantity. Vector quantity is also a physical quantity. However, it has both magnitude and direction. Okay, it has both magnitude and direction. The simplest example, right, is I give you two lines. Okay, I give you two lines, and I ask you to use your ruler to go and measure the distance of A to B. Okay, and then another one, I just ask you to measure the distance of this line. Okay, so if you take your ruler and then let's say this is 4 cm. Okay, and I use my ruler to measure this one 4 cm. Okay, for this one, right, the first one, when I say 4 cm, it is the magnitude. But you see, I purposely put an arrow there, right? That actually represents the direction. Okay, that actually represents the direction. So if I ask you what is the direction, you can say from A to B. Okay, this is the direction. This is what we mean by a vector quantity. It has magnitude. It also has a specific direction. I know this thing is going from where to where. Okay, that is what we mean by direction. From a starting point to end point, we know where is it. Okay. However, this one is what we call as a scalar quantity because there isn't a direction. Okay, we never specify the direction. Well, we can add in an arrow there, but I didn't put in the arrow, right? So assuming that this thing has no direction, I can also draw the line like that and say it's 4 cm, right? They're all the same. It only has the magnitude of 4 cm. Okay, this is a simple example. Okay, this is a simple example. And a very popular example for both of these would be, you will hear this name a lot in chapter 2, but I will just let you know first, briefly, what is the meaning of these two words. Number one, this is what we call as a distance. Okay, you will learn in more detail in chapter 2, and this is what we call as displacement. Okay, displacement and distance. This one is, sorry, a bit messy. Okay, one is distance, the other one is displacement. So you can see distance is the one that we are very familiar with. From last time, whenever your teacher asks you to measure a distance of some line and things like that, you would use your ruler to just measure. Okay, some people would measure from, put their ruler like this and measure 0 here, right? Some people, they might do it the other way around. Okay, maybe they might put their ruler 0 is here. So it doesn't matter from where I measure. Okay, the distance can be, you measure from anywhere, it's fine. There isn't a specific direction. But if I put an arrow and I say that this one, let's give it more meaning. Okay, maybe we are saying a human, a person. Let's call this person John. John is walking from point A to point B. It is different, right? If I ask John to walk from point A to point B versus I ask John to walk from point B to point A. I must give John a very specific direction. Okay, then only he knows from where to where he needs to walk. So displacement comes with a certain direction. Okay, so both displacement and distance, they are a form of length. Okay, they are a form of length in cm. It's just that displacement, right, has got a specific direction. Okay, so with that, we have some examples of scalar quantities and vector quantities. Okay, mass confirm is a scalar quantity. Okay, it has no direction one. Okay, your mass don't have a direction pointing up or down, left or right. Okay, and a fun fact is that if you bring yourself to outer space with a different gravity value, even up to the moon, up to Mars, your mass will forever be the same. Why? Because the mass is the how much matter you have, right? The amount of matter in your body, right? Matter, not metal. Okay, in your body. That is for mass. Okay, there isn't a direction. Distance, we just discussed. There's no direction also. Okay, area, you know, area is just the length times the breadth. There's no direction one. Temperature, electric current, frequency also no direction. Frequency is the time taken for. Oh, sorry, frequency is how many times you do something in 1 second. Okay, frequency is how many times something happened now. In 1 second. Okay, or sometimes they can put 1 minute or 1 hour, right? So for example, you can hang a ball to a string, okay, and then you let the ball swing. How many times the ball swing and come back in 1 second would be the frequency. Okay, how frequent? Okay, so time also, you will notice that all of your base quantity, they are a scalar quantity because they don't have a direction. Okay, volume also, volume got no direction, speed got no direction one, density got no direction. Period of oscillation. Period of oscillation, okay. Period of oscillation means if you hang the same ball and you let it go and come back. Okay. This one means the time taken to the time taken for one cycle. One cycle of anything to happen. When we say one cycle, meaning we let it go and come back. Okay. The best example is you imagine this ball hanging on the string, it go and come back, we will record the time. That time is called the period of oscillation. So it's very similar to time now. Okay, so time, of course, again, don't have direction. Okay, before we look at this one, let's also look at some vector quantities. Okay, let's also look at some vector quantities. So weights. You should have learned before weight, right? Your weight on Earth, your weight on Moon, your weight on Mars, they're all different value one. Okay, why is it so? Because, right, your weight is affected by gravity. Okay, your weight is actually affected by gravity. And when we say gravity, right, you see your Earth is like this. You know that gravity is pointing down towards the center of the Earth. Okay, last time we learned from science, you probably have heard of gravity is always pointing down to the Earth. That's why when you throw apple, go up. Okay, Isaac Newton, this very famous story, right? Your apple will drop back to the ground. Why? Because gravity is always pointing to the direction, to the center of the Earth, right? So at anywhere on the Earth, if you throw an apple, it will always go back to the center, right? So there is a specific direction of your weight. Okay, your weight is how many newtons up, right? And then displacement is the one we talked about. Okay, displacement is not just length, it comes with a direction. Velocity, the formula is displacement over time. So since displacement is a vector quantity, velocity also will be a vector quantity. Okay, acceleration also, because acceleration is change in velocity over time. To be fair, all these all this formula that I write here, you don't have to memorize. Why? Because it will appear again in chapter 2. So to be honest, this is just to give you an introduction, okay, of what are some of the examples. Because all these terms that you see here, you're either going to learn now or learn in the next chapter one or the following chapters. Okay, so don't be too worried. Okay, I don't want you to be too worried. The important thing here is remember scalar quantity is magnitude only. Okay, vector quantity is both magnitude and direction. If you know some of the examples, that's very good, right? Like weight, displacement, velocity, acceleration. Okay, force also has got some direction. Okay, force also got some direction. Momentum also got, impulse also got. This one you will learn later on in not form 2, in chapter 2. Okay, in chapter 2, right? So don't stress, I don't want you to stress. Remember, some of the examples will do, that's good enough. The important thing is you know the definition. You know, if I ask you what is vector quantity, you can tell me that vector quantity has both magnitude and direction. If I ask you what is scalar quantity, you can tell me that it has magnitude only. That's very good already. Okay, if I ask you to give me 2 examples for each, and you can also tell me, that's also very good already. Okay, the rest we will learn more and more as we go on to the later on chapters. Okay, there are some special ones. For example, that's why I wrote here. For example, pressure, work done, and energy. Okay, this one a bit special. Why? Because for pressure, it is force over area. Okay, these are some of the exceptions. These are some of the exceptions. Energy or work done also don't have direction. Power also don't have direction. These 3 are the 3 special ones. Why special? Because am I right that force has got direction, but why force over area then become no more direction already, right? So that is why you need to go to higher levels. Then there is some explanations, better explanations. But for now, pressure, you think of it as a special exception. Okay, special exception. Pressure, work done, or energy, and also power. Again, this table is not a Bible. Don't need to memorize. Just know some examples. That is good enough. Okay. The important thing is know how to explain scalar and vector quantity. Okay. This one will be a very good example to help you to get a better understanding. Question 1.5. The table shows some events involving physical quantities. Complete the table below. Okay, let's go through this one together. Event 1. Okay, there are 4 different events. Okay, and we'll look at it one by one. A plane flies at 700 km per hour from Senai Airport to Kuching International Airport. Okay, the question is this a scalar quantity or is this a vector quantity? My answer is, first question, so I do first now. My answer is, this is a vector quantity. Okay, this is a vector quantity. What is my reason? Because this vector quantity, right, has got a magnitude. And what is the magnitude? The magnitude is here. Magnitude is what? Magnitude is the value. 700 km per hour. Okay, what is the direction? They tell you from one airport to another airport already. Okay, so that is your direction. Right, that is your direction from Senai Airport to Kuching International Airport. Okay. That is why I say it is a vector quantity, because got both magnitude and direction. Okay, got both magnitude and direction. Okay, for event number 2, right? Can any one of you tell me what is the magnitude that you see here? What is that is there any value that you see? We don't answer this one first. Okay, we answer what is the magnitude first. Okay, after you are done with the first one, if you read this sentence, can you tell if there is what is the magnitude? Anything that has a value. Ayman, you want to try? 3 kg? Yeah, that's good. Okay, 3 kg is actually the magnitude. That's correct. Kiva buys 3 kg of flour for his mother to bake cookies. In this description, there is no direction, right? You just say buy the flour for the mother. Okay. Unless if they add in the description and say that he goes from the cake shop to his house, okay, from cake shop to his house, and then he gives you the distance, okay, then it's fine. The magnitude will be that distance, and then the direction will be from the cake shop to back to his house, okay. But this one got no direction. In this description, we cannot tell from where to where, okay. So no direction. When there is no direction and there's only magnitude, this is a scalar quantity. That is why we say that mass, okay, mass is an example of a scalar quantity. That's why you look up at the table there, mass is under scalar quantity and not vector quantity. Okay, the third one, a porter pushes a trolley with force of 25 Newton towards the lift. Okay, so Chloe, this one you want to try? Pushes trolley with a force of 25 Newton towards the lift. The magnitude, you know what is the magnitude?
25 Newton.
Yeah, 25 Newton. You want to try the direction also?
Towards the lift?
Yeah, towards the lift. That is the direction. Okay, towards the lift. So when you have magnitude and direction, this one we call as vector quantity. Got both magnitude and direction. Okay. Last one. Jamal heats some water from 20 degrees to 100 degrees to make coffee. Okay, 20 degrees to 100 degrees. So the magnitude would be 20 degrees and also 100 degrees. But is there a direction or not? Can I say from where to where? This one, no, no direction. Okay, 20 degree to 100 degree. These two are not any place, right? They are just a value from one value to another value. So this one, no direction also. Okay, unless 20 degrees is a place and 100 degrees is a place, another place. So if there is no direction, this is what we call as a scalar quantity. Okay, this vector quantity is the velocity. This one is the mass. And then this is the force. And then this is the temperature. Okay, in case you want to know. If they say 700 km per hour only, right, without the direction, then it's called the speed. Okay, speed and velocity, the only difference is one got direction, one don't have direction. Let me know when you guys are done with this table. Thanks, Chloe. I'm done already. Okay, done. Sarah also done. Okay. Right, example 1.6. Okay, thanks, Sarah. A helicopter is flying at a height of 1,800 meter with a velocity of 2.4 meter per second. Two skydivers of masses 62 kg and 66 kg respectively jump down from the helicopter. They accelerated downwards and take about 3 minutes to reach the ground. Okay, so there are a few things that we know here. But you know what? Let's just look at the what they want in part A first lah. Explain the meaning of scalar quantity and vector quantity. So this is what I said when sometimes they might ask you for definition in exam, right? They might ask you what is the meaning of scalar quantity and vector quantity. Okay, for scalar quantity, right? Can any one of you tell me what is the important word that we have? Scalar quantity must have one thing. Okay, that word starts with M. Can any one of you tell me? What is that one word that you must have in your definition of scalar quantity or when you explain the meaning of scalar quantity? Magnitude. Yes, thank you, Ayman. Okay, magnitude means the value of it. Okay, magnitude means the value of it. So we will say what? We will say that you can write in point form in exam. We will say that scalar quantity are physical quantities that have magnitude only. Okay, only magnitude. Okay, only got magnitude. Okay. What about vector quantity? Vector quantity got one more thing, right, that we know is very important one, other than magnitude. Can anyone just type in the chat box so that I know? Direction. Thanks, Chloe. Okay, direction. Right. So why is it that I want you to go and write this out is because I know some students may say, "Ayo, teacher, up there got already. Down here, you want us to write again." Because when you write, you will remember, right? In exam, then you don't have to purposely go and memorize already. Trust me that 1 month later, if I ask you what is scalar quantity, you can still tell me magnitude. Because I talked about magnitude so many times today. Okay, and if I ask you about vector quantity, you can tell me the important thing, which is magnitude plus direction. Okay, if you can do that, then congratulations, because you can answer your exam questions also, right? So vector quantities are a type of physical quantity also, that one we know. Okay, so don't need to memorize word by word. I remember things by key point also. Okay, I remember things by key point also, and then just fill in the other words. Okay, make sure you have the most important thing, which is magnitude only. This one is have magnitude and also direction. Okay, have magnitude and direction. Or if you want to be even safer, you can say have both magnitude and direction. Okay, but magnitude and direction is good enough. Okay, both also must have. Cannot have direction only or cannot have magnitude only. Must have both. Okay, so that one is the meaning. All right. If I ask, okay, we read question B first. We read question B first. Classify the physical quantities mentioned in the situation above according to scalar and vector quantities. So they want us to read the passage up there again and then see which one is scalar quantity and which one is physical quantity. Okay. I'll wait a few more seconds to let you all finish writing first. Let's start with finding out the physical quantities mentioned. Okay, let's start with finding the physical quantities mentioned. Then only we see out of all those physical quantities, which one is a scalar and which one is a vector. So I've already highlighted the first one, or you can underline the first physical quantity. Okay, Aiman, because you were not around last week, a physical quantity is anything that can be measured. Okay, anything that can be measured, a quantity that can be measured, or anything that has a value, right? So like height of 1,800 meter, this has a value, or this can be measured. Okay, so anything that has a value. So velocity is also another one. Can you guys tell me any other physical quantity from this passage? Still got what physical quantity here? Height is one, velocity is another one. When you read the sentence, yeah, there's mass and there's time also. Okay, very good. Thanks, Chloe. So there's mass, okay, of these two. And then there's also time, 3 minutes. Okay, there's one more that we didn't write because they didn't state the value, but they talked about it only. Okay, they talked about it but never state the value, which is accelerated downwards, this one. Okay, although we don't see the value, right? But just so you know that acceleration can be measured. Okay, acceleration can be measured. Like for example, if you sit in your parents' car, okay, if your parents drive faster or drive slower, you will see that the speedometer get faster or get go higher or go lower one. Okay, so that one talks about how fast the speed is. Okay, how fast the speed is, and acceleration is talking about how much the speed change. Okay, how much the speed change. So if I can measure the speed, or I can measure the velocity. Okay, if I can measure the speed, I can also measure the acceleration, because acceleration is how fast the speed change. So I'm going to say like this now. Let's write our answer like this. So we are going to list out a few scalar quantities and a few vector quantities. Okay, if you don't want to put dot dot, then you say scalar quantities are what, same one. Okay, scalar quantities, number one, the height here, right? The height is a scalar quantity because height got no direction one. Okay, height is a form of the length here. Okay, height got no direction. Velocity, is it scalar or vector quantity? You can type S or V. S stands for scalar, V stands for vector. Okay, S stands for scalar, V stands for vector. Velocity, is it S or V? Vector. Okay, thank you. Thanks, Chloe. And then mass is scalar. Just now we did already earlier. Mass got no direction one. Then we have acceleration. Acceleration is a vector quantity. Okay, last one is time. Okay, the time is your scalar, right? So just this few, and then we are done with this question already. Okay, there are no more other physical quantities here. Okay. Right. So in every subtopic, right, usually I like to put down some objective questions. Objective questions, right, although very short only, but it can help to test your understanding. Okay, it can help you test your understanding. Okay, so let's do a few together. Let's do a few together, and I'll give some as your homework lah. Maybe you can try at home and see, and then next week also we can discuss because there's quite a lot here. Right, a very simple question that they can ask. Okay, a very simple question that they can ask in question 1. A physical quantity is a quantity that cannot be derived from base quantity. Okay. B, a quantity that contains magnitude and direction. Okay. C, a quantity that cannot be measured. And D, a quantity that can be measured. Which one do you think a physical quantity is? A, B, C, or D? We just only talked about it. D. Yeah, thanks, Iman. D, correct. Okay. Next one. Which quantity is a base quantity? Chloe, do you want to try this or not? Because last week you were here. So is this one of the 7? You look at the 4: resistance, potential difference, electric current, electric power. You see whether this 4 is one of the 7 base quantities or not. Which one is it? Okay, if you're not sure, it's fine. You can just say that you're not sure.
C.
C, yes, electric current. Okay, I think this is a very good question. You know why not? All these things look very similar, no? Electric power and then potential difference, resistance. They are all actually related to one chapter called electricity. Okay, electricity, you will learn all these words later on. But electric current is the only one that is the base quantity. Okay, only one that is base quantity. Okay, and then for question number 3, right? Which physical quantity has the correct SI unit? Okay, which one has the correct SI unit? Quantity of matter, we have mole. Temperature, they say is degrees Celsius. Mass, they say is gram. Time, they say is hour. There's only one that is correct. And which one is it? Any one of you? A, yes, quantity of matter. Okay, this is something that you will learn in your chemistry later on. Okay, so don't worry, you will see a lot in your chemistry later. Temperature is not degrees Celsius, right? Temperature, the correct SI unit is in Kelvin. For mass, you guys know is what not? For mass, the correct SI unit is what? kg, right? Yeah. And then time is in seconds, not in hours. Okay, so that's why this one all Salah. Only A is correct. Right. And which one is not a derived quantity? Derived quantity, not derived meaning is base of, not derived. If they say derived means it's derived, but not derived, that means the opposite of derived is base quantity. So which one is base? Just now we already did electric current. There's also something called luminous intensity, which is how bright something is. Okay, these two are derived. These two are base, sorry. Derived is volume, because volume is length times length times length, or length cube. Okay, length times length times length is length cube. So volume you can derive from other things. You can derive from length, but electric current cannot. Luminous intensity also cannot. Okay, so you can see that as long as you remember the 7, then you'll be fine. Okay, maybe I go to another question. Let me see. Question number 8. Any one of you? Question number 8. we jump a bit up. Density is a derived quantity, okay? This quantity can be expressed as, which one do you think is correct for density? You have learned before last time in science? A, yeah, A is mass over volume, right? Correct. Density, the symbol looks like this. It's actually a Greek letter, okay? We read it as rho, R-O-W, rho, okay? Mass over volume. Okay, force over area, right? This one is actually pressure. Ayman, can you tell me? Ayman, you tell me when length multiply with length, what do you get? Length multiply with length. Yeah, length times length. You get, correct, you get length times length, you get meter squared. That's the unit, okay? That's the unit, okay? But if I ask you what is the quantity, what is the quantity, meaning the name, okay? The name would be area. Okay, length times length is meter squared, that's correct. Huh? Right, force times displacement is actually what we call as work done. Okay, work done. You learn this in science form 3 already, but if you forget, it's fine. Okay, if you forget, it's fine. Just know that force times displacement is work done. I know I've roughly seen, although I don't teach science, but I've roughly seen what you have learned from 1 to form 3, and this is what you learn in form 3, force times displacement. Okay, like I said, don't worry about what you learned before. Form 4, form 5 would be almost like a new chance for you to relearn things. Okay. We haven't done anything that is vector quantity yet. Question 9. Which quantity is a vector quantity? Vector quantity. Ayman again, which one is it? Which one is a vector quantity? Velocity is a vector quantity. I'm talking about question 9, though. I think you're looking at question 10. For question 9, which one is a vector quantity? A, B, C, or D? Remember not just now we talked about how acceleration, yeah, thank you. Acceleration is a vector quantity, right? Remember in this subjective question, we already did and say acceleration is a vector quantity, right? Yeah, so this one would be acceleration. Okay. And then let me see. Okay, can we jump to question 25? Okay, question 25. What is the difference between scalar quantity and vector quantity? Okay, what is the difference between scalar quantity and vector quantity? Today we learned that scalar is magnitude only. We also learned that vector is magnitude and direction. So let's find out which one is the correct one. Let me know if you find out the correct one. Scalar quantity has magnitude only. Vector quantity has direction only. Okay. Part B. Scalar quantity has magnitude and direction, while vector quantity has magnitude only. Okay. Okay, maybe I should tell you what is right and what's wrong straight up. Scalar quantity has magnitude only. This one is correct. Vector quantity has direction only. This one is wrong, because vector quantity also has both magnitude and direction. So ini salah. For B, it is wrong. Why? Because they say scalar got magnitude and direction. No, this is vector, not scalar. And then vector quantity has magnitude only. This one is scalar. So this one's wrong. And then part C, scalar quantity has direction only. No, scalar quantity only has magnitude. So straight away we know it's wrong. Scalar quantity has magnitude only. That's correct. Vector quantity has magnitude and direction. Okay. Right. So that's how you see so far, the objective questions can roughly tell you what they usually ask in exam. What is base quantity and also derived quantity. Another one is scalar quantity, vector quantity. Okay. Can we do question 31 also? Which of the following symbol is a SI base unit? Must be SI and also a base unit. Okay, it must be SI and also a base unit. A, B, C, D. Which one is it? Yeah, correct. Thank you, Chloe. C. This one stands, this is for power. Okay. Yeah, thanks, Sarah. Also, this one is for temperature, but temperature, right? The unit is Kelvin. Okay, this one is for volume. Okay, this one is for volume. So temperature, the reason why we don't take degrees Celsius is because it's supposed to be Kelvin, right? It's not SI unit. So only Kelvin is correct. Okay. All right. I think we are pretty much done. The rest, right? The rest, can you guys try yourself? Okay, as homework. I think you can do very fast. Okay, you take some time to try yourself. Next week I'll give you the answers. Okay, you can ask me if you have any question. Like I said, this first subtopic is honestly quite chill only. Not many things to remember. That two types of quantities. Okay, so you must remember physical quantities got two ways we can split them up. We can split them up into base quantity and also derived quantity. We can split them up in, today we learned scalar quantity and also vector quantity. If you know this SPM, you are very good already. If you know the meaning of all the four quantities, then you are very good for SPM already. You're good to go. Okay. Okay, now all the, oh, Aiman, you learn in BM. Is it okay? You probably get, but so far can follow. So far can follow. Yes, okay. Because Aiman is telling me that he learns in BM. Chloe and Sarah, they learn in English. Okay, so our class is in English, so I hope you can follow still. If anything, you let me know now. Okay, I can slow down for you. Okay. Aiman, what school are you from? Oh, I see. Okay, no problem. Let's continue on with 1.2. Okay, 1.2 is not so dry already. We got a bit of maths, a bit of graphs, but it's not difficult maths. Huh? Okay. 1.2 is on scientific investigation, and that is the last subtopic already for this chapter. Okay, this chapter, like I said, is very short. So using data from scientific investigation, we can plot graphs and interpret the shape of graphs to determine the relationship between physical quantities. So scientific investigation, right, is just a very Chang'e name to tell you basically scientific investigation is what we call as experiment in simple words. Okay, in experiment and also writing a report. Okay, experiment including how you analyze whatever results that you get up, right? So you can think of it as experiment, because usually when you do an experiment, you will write down your results and all, right? And then now we teach you how to analyze your results using some graphs. Okay, using some graphs. Okay, so scientific, using our results from our experiments, we can plot graphs and interpret the shapes. Okay, so in this part, I'm going to teach you what are some of the shapes that you have to know and to know their name. Okay, and these shapes will tell us the relationship between two different physical quantities. Because so far in maths, whenever you draw graphs, you're always drawing between two things, one. Okay, usually we say it's called X here and then Y here, right? So I can also put other things. Okay, I can also put other things. Like for example, I can put volume here and I can put mass here. That is also can one. So if my graph look like this or my graph look like this, it will give me a relationship between the volume and also the mass. Okay, it can tell me some relationship between the volume and the mass. Like if you get some data and then you plot the values, right, it will tell me, oh, as my mass increase, my volume also probably increase. Okay, because if your value here become larger, your value for your volume also probably become larger. Okay, you see it gets bigger and bigger, right? So from there, we know roughly the relationship. That's the important thing that we're talking about. In an experiment, graphs are plotted to see how a responding variable, which is plotted on the y-axis, responding variable, changes with the manipulated variable on the x-axis. Okay. Starting from the first graphs, there are some graph basics that I want to go through with you first. Okay, there are some graph basics that I want to go through with you first, which is on linear graph equations. So last time you have learned before that a straight line graph can be written as y equals to mx plus c. Okay, y equals to mx plus c. Okay, and then there are some meaning to this m and this c one. Okay, I don't want to test you guys lah, right? So I tell you straight away, m represents something as we call the gradient. C represents what we call as the y-intercept. Okay, so this one very important for straight line graphs, because all of your straight line graphs, you can write it in this format. Okay, all of your straight line graphs, you can write it in this format. And if you know this, if you write it in this format, you know it in this format, you would already know what is the gradient. You would already know what is the y-intercept. Okay, so let me ask you, if I have y equals to 2x plus 5, okay, this would mean that your value of 2 is the gradient. The value of 5 is the y-intercept. Okay, so gradient here actually means what? Okay, gradient here actually means, if you do gradient in Form 3 and you didn't know what is the meaning, now you know. Gradient actually means the steepness of the graph. Okay, or how slanted the line is. Okay, how slanted the line is. If I say that a line is very steep, that means it's very, very close to a straight line. Okay, if I say that a line is not very steep, that means what? That means it's maybe not standing up very straight. Okay, like when you climb a mountain, let's say you climb some mountain. I don't know if you guys climb Broga Hill before, not a very popular place to do mountain climbing. But basically, if I say that the mountain is very steep, right, that means the mountain probably looks like this, and then it's very, very hard to go up, right? can imagine it's very hard to go up this mountain because it's very, very steep. This is what we call as very steep. Okay, so difficult to climb mountain is called very steep. Easy to climb mountain is called the one that is not so steep. Okay, maybe flatter like this. This one is easier to climb. Okay, so this one is steep. This one is not so steep. Okay, so if your gradient value is very high, that means it's very steep. Your gradient value not very high, that means it's not so steep. Okay, so maybe I give you an example. This gradient is maybe a 20. This gradient is maybe a 2, right? So the larger the value, the steeper it is. So steep means a very steep line means it's very close to a vertical line. Vertical line meaning like this. Okay, maybe the line is like that and it's very, very close to a vertical line already. It's almost, if you stand up straight like that, this is the steepest line you can ever get. If it's slanted a bit, okay, still very close to a vertical line, then it's still quite steep. But as you go lower, 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 you're getting less and less steep. Okay, so gradient is the steepness of the graph. Y-intercept is very simple. Y-intercept is where the graph cuts the y-axis. Intercept means, the meaning of intercept is where you cut. Okay, if I say I intercept you, when you're driving, when I intercept you, that means I go and, okay, let's say you're driving here. Okay, and then I go and intercept you. When I say I intercept you, it means I go and stop you up. Okay, I can cut your lane and go and stop you in front of that. Okay, so y-intercept means where you cut at the y-axis. Okay, you can see in the graph here, we wrote your C is actually this value. Okay, these are already things you know. So I'm just trying to explain and revise a bit. So gradient means how steep the graph is. Y-intercept means where you cut your y-axis. To calculate the gradient of straight lines, this one you learn in Form 2 maths, your gradient is y2 minus y1 over x2 minus x1. Okay, but if you forget this formula, right? If you forget this formula, don't worry. Basically, right, the y2 minus y1, let's say I give you an example. If I have 2 points and I want to find out the gradient, let's say this coordinate here is 5, 2. Sorry, 2, 5. 2, 5. And then this coordinate here is 6, 1. To calculate the gradient, let's do a bit of revision for maths. Basically, you see this y minus y literally just means you take the y coordinate minus another y coordinate. You can do 5 minus 1, or you can do 1 minus 5. It's the same meaning one. So if on top you start with 5 minus 1, we take the y coordinate minus the y coordinate. Okay, then at the bottom, you are going to do 2 minus 6. Okay, at the bottom, you're going to do 2 minus 6. Because the first one you start with 5 first, the bottom also you must start with 2 first. If this one you start with 1 first, 1 minus 5, then down there will be 6 minus 2. Okay, I want to ask you guys, right? Are you okay with the formula for gradient or not? Because I know you learned before, but I don't know whether you still remember this. Or if you forget already, now that I explained, are you okay with this one? No answer, a bit scary. You understand what am I doing in this example? If no, you just say no, it's fine. Okay, thank you, Aiman. I'm following the formula, taking the y coordinate minusing the y coordinate over the x coordinate minusing the other x coordinate. So we can understand this one? Not really? Uh, So the y coordinate minus the y coordinate over the x coordinate minus the x coordinate. Okay, so this is the gradient value. The y-intercept. Okay, the y-intercept usually is just where the graph cuts the axis. Okay, is where the graph cuts the axis. So whatever this value is, that would be your y-intercept. Okay. So if you ever need the formula, it's already here. Gradient stands for y2 minus y1 over x2 minus x1. You start with whichever y value on top and whichever x value at the bottom. Also no problem. Okay, so as long as the top you start from the same coordinate and the bottom also the same, then it's fine. Then the y-intercept is where it cuts the axis. Okay, thanks, Chloe. And then the equation of 3 y equals mx plus c. Now this one, positive or negative gradients. This one is something that is good to know. Okay, this one is something that is good to know. If you see any line that goes slanting like this, or like this, or like this, okay, for example, this one, this one, this one, you see they're all slanting in the same way, okay? Or even if you have curves, right, that goes this way, or this way, or this way, or this way, as long as it's in the same direction, it's going up like that, okay? It's pointing up. This is what we call as positive gradient, okay? So you will see that for all this graph, there's one common thing. As you increase the value of your x, right? Let's say here is 2 and here's 1. And then here is 4, and then here is 2. You will see that the value will keep increasing and increasing also. Okay, the y value will increase with x. This is what we mean. Okay, as you put a larger x value, you will also get a larger y value. Right? Same for your curves. If you put a larger x value, you will get a larger y value. Right? That's why this is what we call as positive gradient, where the y will increase with the x. What about negative gradients? Negative gradients is when your y decreases with your x. So anything that slants this way. So one slant like that, another one slant this way. Okay, it's going down. So if your straight line is going down like this or slanting like this, anything that slants this way, it means that as your x value increase, your y value also will become smaller and smaller. So if say, for example, this is 1 and this is 2, and this is 2 and this is 5. Sorry, this is 4, for example. Okay, so 1, at first, it's pointing towards 4. And then as you increase your x value, your y value will become smaller and smaller and smaller and smaller. This is what we mean by y will decrease with x. Okay, y decreases with x. And same for the curves. If you ask me how I remember, right, honestly, there's a simple way. I always just think of the letter A. Okay, I always just think of the letter A, and somehow it has stuck with me for a very long time. Okay, there's no specific reason, but the letter A, right, will tell you like this. Positive is on the one on the left. Okay, you write positive first, and the one on the right is negative, plus and minus. Okay, so positive is anything that slants this way, lor. Negative is anything that slants this way. Okay, so if you see your graph, right, slant which way, you would roughly know what is the value of the gradient already. Okay, all this gradient, right, maybe this gradient is positive 2, maybe this gradient is 1, maybe this gradient is -2, maybe this gradient is -1/2, right? It will confirm be -1 as long as it slants in the negative side. If it slants in the positive side, confirm it would be positive, okay? Let me finish this shapes of the graphs first, then we will go. Right, so there are some names of the graphs that you have to know. Okay, if you see that your graph starts from 0 and it's a straight line go up like that, must be a straight line go up. Okay, there's a special name for it. It's what we call as y is directly proportional to x. Okay, y is directly proportional to x. Directly proportional meaning as your x increase in the same way, your y also increase in the same way. Proportional is like ratio like that. Okay, increase in the same amount, increase in the same ratio. Okay, same proportion. Then you have things like this. If your curve is this way, okay, if your curve is this way, then we call it y is inversely proportional to x. Okay, this one for now, I would say yes, you need to memorize, but trust me that as you go on, you will automatically remember already because you will do this so much. Okay, you will keep doing this a lot until you will eventually remember the name and also the shape. Okay, this is inversely proportional. Then when I put a 1/x, okay, y equals to 1, and then y is 1 here, and then 1/x is here, it will form a straight line. In the next class, I will explain to you why. Okay, but if any time when you need to refer, you can come back to here. The important one is this one, directly proportional. Always ask in exam this one. Then inversely proportional is this one. Okay, the next one is y is independent of x. We say y is independent, right? Whenever, however I increase the x value, let's say I put a value of 1, I put a value of 2, I put a value of 3, or I put a value of 4. You see this y will never change no matter what, right? Let's say this y value has a 5. So at different x value, the y also is independent. That means the y is free. Independent means free. Free of the x. Okay, the x will not affect the y. Okay, what x value also, the y will never change, just straight one line only. This is what we call as independent, free of the x. Okay, the x doesn't affect. Okay, this one is what we call as increases linearly. A lot of people get confused at the start when they learn this one. They get very confused between this one and also this one. Okay, these two. So I just want you to know that directly proportional starts from 0, 1. Increases linearly does not start with 0. Okay, increases linearly. This one must remember directly proportional only start from 0. Increases linearly does not start with 0, but the lines look the same, look similar. Okay, what does it mean by increase? Increase meaning if x increase, y also will become bigger and bigger and bigger. Linearly means what? Whenever you see the word linear, it means increase in a straight line. Okay, so at the end of the day for this part, if you see the graph and you're able to say the name, then you are good. Okay, that's what they want to see, whether or not you can say the name. Okay, directly proportional, this one is increasing in a straight line, increase linearly, because never touch 0. This one is decrease in a straight line, decrease linearly. Okay, linearly means in a straight line. Yeah, positive gradient. So Chloe asked if y is directly proportional to x is also positive gradient. Yes, this one has a positive gradient. What else has a positive gradient? This one also has a positive gradient. This one also has a positive gradient. Why? Because they all slant in the same way, right? Remember your letter A, if anything slant this way, then it's a positive gradient already. This one has a negative gradient because slant this way. This one also has a negative gradient. Okay, this one actually is not positive or not negative. The gradient here is actually 0. Okay, but this one they rarely test you lah in physics. Okay, that one is for maths already. Okay, so yeah, a very good question. This one is increases. You see, it goes up, increases. This one also go up, increases, but non-linearly. Okay, linear means straight line, non-linearly means not in a straight line. Okay, not in a straight line. But you are right, this one is also positive gradient. Okay, positive gradient means increase. Okay, the value of x will increase with the value of y, or the value of y will increase with the value of x. This one is decrease, you see, going down. Okay, but not in a straight line, because linear means straight line. So this one is negative gradient. This one is negative gradient also. Okay, that's why negative gradient means decrease, or positive gradient means increase. Okay, so these are all the shapes you need to know. And I also roughly explained to you what is the meaning of y equals mx plus c and how to find out the m. In the next class, we will go through on more of how we find out the gradients, how we find out the c, and so on. Okay. All right, so that wraps up today's class. Before we go, right, I just want to remind you that you guys can try this objective questions. Again, you guys can try all these objective questions. And if you got any question that you don't understand one, you can ask me in the next class. We will explain together. Okay. If you got any questions, do you guys have any questions from today? No? If not, we will stop today's class already. Oh, okay. Chloe, okay. Aiman, okay. Sarah, okay. Okay, all good, Aiman. All right. So for this part, the important thing is know the names first. Okay, know some of the names first. If you are new to this, it will be, of course, a bit hard lah, right? But later on, as we do more and more and more, you will remember better one. Okay, that's what practice are for. Okay, bye bye. So I'll see you guys all next week. Okay, Ken. Bye bye. You guys can go already. Bye bye. Welcome. Bye bye.